All right, in today's video, I'm going to actually review a couple things. We've got a bug to fix, I'm going to show you a little quality of life improvement, and I want to tackle the homework that I assigned in one of the previous videos. So I'm going to integrate an audio detector into this so that if we do something like swoosh our sword, then the slime heard me. Okay, so we'll be building that today as well. This is going to be kind of fun and loose and a little bit different than normal because I'm just kind of figuring it out as I go, so you can follow along with my thought process. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge. So let's get into this. What this is kind of going to be a different video than what I typically do. So my plan is to fix this little bug that I found in our PlayerSensor. But also, I kind of want to take on that homework assignment I gave, which was the audio sensor, and just kind of tackle that with you guys. So this is unscripted. I didn't plan it out. I didn't develop the feature beforehand to make sure I caught any kinks. So the result might not be perfect, but I think that's okay. And I kind of want you guys to, join me in that process and see what it looks like for me. So hopefully this will kind of just show those of you who like to follow along how I think and how I work through these kinds of problems. Okay, so first I want to demonstrate this bug, and I've gone ahead and made it so my slime doesn't move, and I've enabled my little nodes, my label for kind of debugging this. And when we enter, okay, the target is the player and the distance is 147, and that's all good. And we can leave, and after the cooldown or the search timer, which is 2 seconds, then it resets. Now, the bug comes in because we didn't handle something with that search timer that we should have, and it just kind of slipped my mind. I didn't think about it, but we enter the vision cone, and I made it so my enemy doesn't move, so this is easy, right? Now, if I leave and come back before he loses me, you notice how the target just cleared. Because what's happening behind the scenes is, if we look at our script on our PlayerSensor, every time we have a body entered, we set the target, and anytime we leave the area, so anytime we leave this collision area, we set our search duration timer. Okay, so that means once we've entered and left, it doesn't matter if we re-enter, this timer is still counting down. And that means that eventually it's going to hit this condition and it will clear the target even if we're standing within the vision cone. And obviously we don't want that. There's probably several ways we could go about this, but as far as I can tell, the simplest fix is that every time we enter, we simply reset that timer to 0. Oops, not equal negative, but equal 0. Then what this will do, because our code checks if the timer is greater than 0, so we enter it, it sets the timer to 0, it means it's no longer going to do the processing, so this should be good. Now I should be able to enter the area, get identified as the target, then leave, and then come back, and I'll stay the target. All right, let's go ahead and jump over here and let it clear. There we go. Enter, leave, re-enter, and I'll stay the target. So pretty simple little bug, just one tiny bit of code to fix it. There's other ways that you might need to fix it. If you don't have a search timer, then you probably don't even have this bug to begin with, but there we go. Okay, now I want to throw in some goodies with this one as well. So for those of you watching, you're going to get some little bonus pieces. One tiny thing I want to do actually just relates to this new enemy script that we've written. So when we look at this, we have the ability to change the face left on start. And like if we look at this slime here, he actually has it turned on, but you wouldn't know by looking at him because he's facing to the right. Okay, so I'd like that to update, and this is pretty straightforward. So we'll just go back to the script. It's already a tool script, which means it can run in the editor. I'm going to start by just setting a simple setter function on this variable. So we'll say set and then value. And then of course we can I'm going to go ahead and just set face left on start equal to the value. Okay, so that's not going to change the functionality, but then we'll also call a simple function. We can just call it update face left. Okay, and then obviously we need to create it. So I'm just going to go to the bottom of my script down here somewhere and make this guy. Okay, and you'll notice I'm not passing the value. We don't really need it because we've already got it stored locally within this class. And I'm going to actually only make this run in the editor, I guess, because it'll work fine in game. So we'll say if not engine, how do I spell engine, guys? Engine, is editor hint. Yeah. Then we can return. And then what we'll do here is I'm just going to go through and I'm going to flip the sprite. But because we don't necessarily have a reference to the sprite in the editor when we're doing this, I mean, we have a sprite here, but we grab that in this setup code. Okay, so we don't actually have a good reference to it. So what I'm going to do is I'm just going to loop through the children, find the sprite, and then go from there. So we'll say, not if, I'm going to say for C and get children. And we'll just check if C is sprite 2D, then we can set the flip horizontal. So C dot, let's see, dot flip H equals, well, I'm just going to set it equal to face left on start. So that way, if we toggle it back off, then it'll face the other way, since they're Booleans essentially. Okay, that should just work fine. So now I'm going to go ahead and save this. I should be able to just change this at this point and see it update. So there we go. You can see now, I mean, I guess the vision cone we might not always have visible, but you can see that at least that sprite flips. Okay. And you could go further if you want to, but I think this is just a nice little quality of life thing to make it easier to see what's going on there. Okay, so now it's time for us to talk about how we're going to implement this homework assignment, right? Which is the audio, like an enemy, like a player listener, maybe. And you know, this is kind of a tricky one because I suggested it and then I kind of kicked myself in the butt thinking, I don't really want this in the game and it could get out of hand. It could get hairy pretty quick. But I think we can find a good kind of middle ground solution. And it's going to require a little bit of refactoring from what I can tell. But the sensor itself, I want to be really simple. So I'm going to just come into this slime and I'm going to start building it here. And then we can go from there. So I'm going to add a marker 2D and just drag it over here. You know, maybe this could be something else, but I'm going to rename it. I'm going to call it, well, actually, you know what? I don't want to just drop it in. Let's do this. See, I'm recording live. I'm not going to cut this out. I'm actually going to just create a script. Let's do this. So we've got our enemy scripts sensors. This is what we should be doing. Create new script. And then I'll call this one audio sensor. Okay. And then this will have a class name. Boom. Oops. I hate when I do that. Okay. Class name is going to be audio sensor. And this will extend. I want it to extend to marker 2D, I think. Okay, lowercase e and extends. Okay, so we're going to have to think about this. We're probably going to need the ready function. Don't think we'll need the process function. And then let me go ahead now and add one of these to the scene and we can start talking about it. So just add an audio sensor. There we go. Would be great to create an icon for this. There we go. So there's our audio sensor. Now, how do we want this to work? I think anytime our player makes audio, we want this to be able to tell if there's an audio, you know, sound effect, be able to detect if the player or if the enemy can hear the player. So that means that we have to be able to distinguish between enemy and player audio, or maybe player audio and any other kind of audio. So they're only going to care if it's player audio. In addition to that, I think we need to be able to maybe associate some sort of like a magnitude or volume level with these audio sensor events, because let's say the player footsteps are supposed to be quiet, but like a jump land or an attack is supposed to be a little bit louder. We want to be able to differentiate that. And I think it would be hard. I think it would be very difficult to do that based on the waveform that we play back itself, and maybe too expensive. And so I think we might need to have like an artificial value that we assign to these different sound effects. That complicates things. But if you're making a stealth game, then I think this is probably the way to go, because then you can configure and, you know, nerf things if they're overpowered, or, you know what I mean, just kind of adjust it on the fly as you test. And there's some robust ways we could do that. We're not going to do a super comprehensive. We're going to do kind of like a quick and dirty implementation of that. But we need something. We need some way to determine magnitude. And then on top of that, I think that's pretty much all we do. Maybe when we hear the player, we just assign him as the target, just like we would with any other, with the player sensor. Okay. What we have to be careful then with is if our player sensor and our audio sensor can both hear the player, then we could run into a situation where they're both setting blackboard values at the same time. And so you know what? I'm almost tempted to make this audio sensor just a part of the player sensor. Yeah, let's do that. So I created this script for no reason. Now you could create it separate, but I think for simplicity's sake for this kind of game, I mean, I'm not making, I don't know, Thief. I don't even know if Thief was a great stealth game or not. It's been a while since I played it. But let's just go in here into our player sensor, okay? This way, if we combine them, it's generically named and we can utilize the same like searching timer and things like that. And so, you know, I think that what we do want though is to maybe export a value. I'm going to say use audio sensor because maybe some of the enemies are too dumb for that and some aren't. And then we're probably also going to need some sort of, because you know, with the visual portion of this, we've got this vision cone that doesn't translate well to audio. Audio would be probably all around, and so we just need maybe a distance. So I'm gonna export a variable for that, and we'll just call this like audio detect distance. Maybe I'm gonna use dist, and I'm gonna set this to a higher value for now. Okay, and I think potentially we might need to build in like a sensitivity to this. Actually, let's go ahead and do that as well. So like maybe what this is like a minimum volume to activate the sensor, right? So like, yeah, I guess that works. Minimum volume, minimum audio. I don't know what to call this. Min audio sense. It's a float. And I think what we'll do is we'll have to put all of our audio on a scale of maybe 0 to 1. So I'm going to just set like 0.5 as the default. So like a highly sensitive enemy would be really low, like 0.1. And otherwise it will be, you know, this is like 50% as opposed to full volume. So they don't have to have a really loud sound, one being our loudest. And we're going to have to determine how we can handle that. But this is where it gets fun. And this is why this is such a scary episode to record. Okay, so there we go. Added a couple variables here to my player sensor. Okay, so now obviously if the player makes a sound, we need a way for that to get communicated all the way to this sensor. And because of the way we've built this game, we actually have a natural way to handle that. We could use one of two systems. We could use the message system, which I think would be fine. But what's even better, in my opinion, is just to tie in to our audio system. Because this is global and we're already calling it to playback spatial audio. Now, there are a few sound effects that we're playing on our player that aren't using this, so we would have to refactor them to use this system. But yeah, we could just build it in here. And then anytime we play, we could just add a signal. So let's do that now. I'm going to add a signal right here. And I think what we can do, we can handle this a couple different ways. We'd have a generic signal that just says like, audio effect, you know, or something like that. I think the only time we need it in this game, because obviously the human can hear, I mean, I guess you could use this to make an accessibility feature too, but I digress. I'm gonna just spiral out of control. But that would be cool too. So maybe you need some visual feedback to like blip where enemies are, the direction of enemies, if audio is important to that. But for now, we're just concerned about the enemy hearing the player. So what I'm gonna do is I'm gonna add a signal of like player made sound. Okay, and that should be an underscore. And so what I'm going to do, and maybe you could shorten this, but player made sound. What we need is we need a position and we need a magnitude. So the position is going to be a vector 2, and then the magnitude will just be a float. Okay. So then what we can do is we can come back to our player sensor, and here on our ready, when we connect all of our signals, we can just come in and change this. So we'll just say something like audio dot, what is it? Player made sound dot connect. And then we need to make on player sound, something like that. Let's go ahead and make this function down below. Boom, on player sound. And there we go. We obviously have those two things, right? So we have the position and we have the magnitude. Is magnitude the right term for that? Let's just call it volume. Okay, and this will be a float. And there we go. We're going to use those, so that warning highlight will go away. Let's go back here and let's change this to volume. Okay, there we go. So now anytime we emit this signal, our player sensor is already going to pick it up. We could just print a message, right? It's like player made sound just to help debug it. And then let's go ahead and add the position and the volume to this debug. And I'm going to add in between it, maybe like a space or something. Okay. So this will let us know once it's working, because this should already start. Let's go ahead and run and make sure we don't have any bugs already in our code. And it looks like we do not. Okay, so that's good. I'm actually going to turn off debug collision shapes. Don't want that. Okay. Okay, so we've hooked that up. And now we need to come in here and we need to be able to emit this signal, right? And so what I'm going to do is let's go down. We've got a play spatial audio or play spatial sound. And we've built in some things in here. I've got the audio. We have a position. We can use that. And then we have ignore pool, which is set to false. And then I think, you know what I think we ought to do? I think we keep this as is. And then we go like this. We go function player spatial sound. Or we'll just call it player sound. Okay. That way I'm not going to complicate this any further. We are going to complicate our player a little bit, but at least it won't affect anything else. Okay, so the player sound is going to need these same values. You guys, I'm second guessing this. This is what I do. This is what I do when I'm prepping for my videos. Okay, forget it. I'm just going to make it part of play spatial sound because then it won't break any existing thing I have there. We're just going to have to make sure that we use these new variables. So we need we've got the position, we need the volume, and we need a way to determine if it was the player that played it. So I'm going to say was player. Yeah, this will be a Boolean. And we'll set this. Now, because plays, my favorite kind of false. Because we have this ignore pool Boolean, which is false, anything that comes after it is also going to be an optional argument, and so they need to have a default assigned as well. And in order to make this more readable, we can do something like this. And let's see, where's the end? Boom. Okay, so we can kind of separate these onto different lines if we write it like so. And then I guess in addition to was player, we're going to have the volume. Now we're not actually going to use the volume to control it. That's why I kind of struggled with that name. By default, we'll make the volume 0.5. So just like a middle average is what we're going to call that. Now we're getting these highlights because we're not using those, but that's okay. So if ignore pool, do that, else do this. Okay. And then when we're done with all of this code, what we can do down here is we can say if was player, then we know that the player made the sound, right? If we pass that in. And so what we need to do then is we need to take our player made sound and emit it at this position with the volume level that we pass in. There we go. We're getting close. We're getting close. So let's just run it again. We should be able to still make sound effects. Okay. And now nothing is set to have was player true. So that's not going to be happening until now. So that's what we got to go do. And that's what we had to go do is hook up our player so that he starts using these new parameters. Okay, well, let's open our player. I've got him open already. Okay. So we have a couple things in here. We have some audio streams like the hurt, jump, and land. We're gonna have to remove the use of those. Um, you know, that was just me giving an example of how we could use it. And most of our audio playback, as I recall, happens throughout our various states. Well, let's go ahead and open the player script. And I'm going to close breakable and damage area. I'm going to close a couple of these things that I don't think I need. Okay. Oops, I just closed the player sensor. I didn't want to close that one. Open that again. Okay. So looking at the player, was it play spatial audio? I don't think we do that here. In fact, we could do a Shift Control F and see if we could find that throughout the project. Find play spatial audio. And then I want to do it in our player folder maybe. So let's do this and go down to player. Okay, select current folder. Includes scripts. Excludes. No, we don't need to do any of that. Okay. We don't need shaders either. I'm going to go ahead and find. Let's see what we come up with. Am I typing that search wrong? Play spatial sound. Yeah, I am. Okay. Let's do it again. Play spatial sound. Okay, there we go. This is going to give us all of our results. So like this is the ground slam ability we're looking at here. See, I just got a message, got distracted. So what are we doing here? We're going through, this is our ground slam. So some of these sound effects, like this dash audio, I think is pretty loud, I'm going to say. So we have to decide if we want this to ignore pooling or not. I'm going to set that to false. And then was player is true. And then the magnitude, we can set this higher. Let's set this at like a 0.75, okay? I'm gonna go ahead and copy these values because we're pretty much gonna be using something like that everywhere we go. Okay, so down here on the exit, this is the boom audio. This is loud. This, for me, is gonna be a 1. Okay, that's like the loudest it gets. I'm just arbitrarily rating them in my head as I go. Destroy audio, play spatial sound. We'll say that this was made by the player. And maybe 0.75 is good. And then lastly, another destroying stuff. Okay, there we go. We've just updated the ground slam. And so let's go ahead and just test that. And let's see if ground slam, we should get like something coming out down here if the player or enemy senses it. Wrong button. Hey, look at that. Player made sound. Player made sound. I'm not sure why I'm getting a 1. I'm not sure why I'm getting a 1 on that dash, but it's working. We've got a position that the sound was made, and we've got a value of 1, 0.75. Let's go back and let's check play spatial sound. Was player. Oh, look at that. What did I do? I cast that as a Boolean, but it should be a float. Okay, let's try it again. And so we should have had a 0.75 and a 1. Perfect. So now if I come over here and break this, and we're going to get a series of sounds. Boom, 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 boom. Okay. Pretty cool. I'm liking how this is working. Oops. I'm liking how this is working so far. So I'm just going to go through and hook these up because that's kind of the step we're at right now. And let's go to search results. So I still have them. Yeah. So like death, we don't really need it here. Not going to worry about that one. I am going to do something with this one though. With my pooling, this is something that I think should ignore the audio pool. That way, if there's a ton of sound going on, this sound effect plays out because it's a little bit longer. It's about a second long. Okay, save that. Dash, easy peasy, 0.75, just like the ground slam of that same audio. This is the ball. I feel like this is slightly more stealth, but not terribly so. Let's put this at like, it's not super loud, but let's just put it at 0.5 maybe. Okay. And in fact, I'm going to go back and I'm going to copy that. I think a lot of our sound effects are going to be around that range from here on out. The morph out audio, we'll do the same thing, 0.5. There we go. Morph audio. And let's see. Attack. Our attack state? Yes, our attack state. This is actually kind of quiet, right? It's just the whoosh. So I'm going to go ahead and set it appropriately. Now, those are all the sound effects I have, but let's look at a few other states on my player because I'm pretty sure I've got some more audio. Idle, run, jump, run. Do I have footsteps? Did I put footsteps in here? I don't think I did, right? No, I've got the land and jump. Okay. Those aren't terribly loud, but I feel like, okay, let's go to jump. The jump sound effect should be fairly quiet, but we're playing this back. We're using reference to this jump audio, right? And so what I want to do is instead of that, I want to bring in a reference to that actual sound effect that we're going to play. Is that in our player folder? Player? Oh no, I made an audio folder and it's empty. I think I just dumped all the audio in the general folder. So I need to learn how to spell. So general starts with G, audio. Okay, what do we got? Jump. Boom. Let's bring that in here. And then what we're going to do is we're going to remove this. That's going to show us where we need to fix it. And that's right down here. Okay, jump audio dot play. I'm going to grab attack. And I'm going to just grab this whole line of code. Come in here. Select that line and paste. And then, of course, this is, what is it called? Just jump, probably. There we go. I think 0.25 is good for the jump. The land is a little bit louder. So we'll copy that. And we're going to open our fall state, which has the land audio, if I'm not mistaken. There it is. Land audio. And you know what's funny is I've got all these things in here. Look, here's the land audio. See this? I could show it in file system, which, I mean, I was there, but let's go ahead and bring that in. And then go down here where we played it. Paste. And this is called land. And I'll make this a 0.5. Okay. We've done jump, land, and it looks like we need hurt. I'm going to delete that. And then let's open up our take damage state. Should be where we play this back. Right there. Where do we use for that? Is it the arg sound effect? I just deleted it, so I don't remember, but it should be that. Arg. Okay, let's go down here. Paste it. Let's make this like a 0.45. I don't know, whatever. And then this is, there we go. I don't know if I missed anything. Let's run it and see. Got something going on in my debugger. Oh, I've still got a reference to these. Where is this? Oh, this is in the ball state. Okay. Let's delete that. Which means we're going to have a couple things to update here. This is the jump audio, so that should play jump. And then this one is the land audio, so that should play land. And this is, what do we do land at? 0.5. And of course, I don't have either of those sound effects referenced here. I have morph. Let's get jump. Boink. I could have got land right there. It was right beneath it. Save that. Let's run again. Nice. Okay, that's working pretty good. We're picking up the player-made sound. The only entity in the game that has that right now is this Slime 2 because he's got a player sensor. And we have use audio sense on. Let's go ahead and just save this. And let's see, I'm going to stop. I'm going to save it, turn it off and save it, save it and save it again. Let's turn it back on. Now we shouldn't get anything now. Oh, maybe not. I guess we haven't done that quite yet, have we? Let's go ahead and open our player sensor script. And I can close a lot of this stuff now. Okay. Player sensor. Oh yeah, we're not handling it in any way. So actually, you know what we could do is If we don't want to detect the sound effect, if we turn that off, use audio sensor. Am I on the right thing? Yeah, there it is. Then we can just do that right up here. If use audio sensor, then we do that. So now we shouldn't be picking up any effects. Yeah, so if you've got an enemy who can't hear but has a player sensor, there we go. We've got a solution for that. Make sure this works. Turn it back on. Run it again. And there we go. You can see I'm getting sound effects coming through. Cool. We're partway there. Let's go ahead and see if we can finish this out by hooking up the rest of what we need to do in this player sensor script. Okay. So on player sound, we don't need to print anymore. I'm going to keep that there for debug purposes. So I think what we need to do, I feel like we need some sort of, is the word attenuation? I think so. Like we need some sort of way, some way to make it so that maybe if the player's at the extent, at the very edge of the enemy's audio hearing distance, it's quieter. And obviously, if he's past it, right, we've got this distance here, 256. If the player's further than that, then maybe it can't hear anything at all. In fact, we almost could maybe get rid of that and just make it the same for everybody and just use this minimum audio sense. You know, I'm not quite sure. I'm going to keep them both here, though, for now, just to be safe. So what we need to do is we need like the distance, right? Because we have positions, but we don't have a distance. So we can say sound distance will equal, and then we can just simply grab one of these. So like this has a position. So we can grab our global position and say distance to, and then we could use the position here. And we'll look at this distance to. There's also like a distance squared to. Returns the square distance between this vector and 2. Man, I'm whistling a lot. This method returns faster, so preferred if you need to compare vectors or need square distance for some formula. I wish I knew a little bit more about squared distance. I'm going to do a quick Google search on that. I can't find much in addition to this, and I don't want to wait too long, so I'm going to go a different route. I'm going to print this out. And then let's go ahead and print out as well. Let's do the squared distance here. A distance squared to, yeah. Let's do that. Let's just see what the value is. Whoa. That's a big number. That's a really big number. Hurry. Ooh. Okay. Okay, so if I take like 112 times 112. Okay, yeah. So this is literally just that number. I guess it's cheaper, less expensive to calculate because you don't have to get the square root. Interesting. Okay, well, that's not useful. I mean, it could be if we thought hard about it, maybe, but I don't want to think too hard about it. Okay, so we can calculate a sound distance. And we can see this is 112 pixels. So let's go back. So let's go back to the game. If I come over here, now see, this is like 300. Honestly, I don't know what would be a good distance. I mean, I think, yeah, over here is still not even quite the max distance, and we can barely see the slime on the edge of the screen. So that tells me that I might either need to reduce the default audio detect distance or handle this differently. Let's go ahead and just make it 200, so it's a little bit less of a distance, and then let's move forward. So, okay, we're calculating, or we're getting the distance, and then next what we need to do is we need to figure out how we want to handle the fall off of this. I think one thing we could do is we can use this value because we have a sound distance that we've calculated and we have an audio detect distance. We can use that to convert it to like a 0 to 1 kind of a value, because you know, like if the distance of our audio was 243, that was further away than 200. So we know that it's like less than 0. Okay. So let's figure that out real quick. So let's say like variable, I'm just going to call it D for a second. This is a float equals, if we start by taking our sound distance and dividing it by our audio detect distance, we could print that. And, you know, I can just keep this running and just keep adding some of this code. Let's see. Okay, so you can see that's like a 0.5, 0. Hey, look at that. Okay. So this is a high number. Now, what we want, though, is we kind of want the inverse of this. And I'm not sure the best way to do that, but I'm going to just go 1 minus. And then what I'm going to do, so that's going to be, let's save that. There we go. So as we get closer, it'll get closer to a 1. Okay, that's like a 0.8. Pretty good. Now, the next thing I want to do is I want to clamp this maybe. Clamp float. Oops, what did I got? 1 minus blah, 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 blah. That's our value. And then the minimum is 0 and the maximum is 1. Okay. Okay, so now we've got a number between 0 and 1 that gets smaller the further away we are. Cool. Okay. Now I think the other thing that we can do that'd be kind of fun. So we have a distance as like a ratio. You guys might not like this, but this is just how I'm figuring this out. Next, I think what we need to do, we have a volume. And then we have a minimum audio sense, which I think relates to the volume, maybe. I'm not quite sure how I want to do that. But let's say that our volume, maybe it gets multiplied. Maybe it gets multiplied by this number. So then we have a new value that's called like perceived volume, right? So this will equal the volume multiplied by this D, because this number, if we're really far away, then even if the sound was really loud, then maybe the enemy can't even hear it. Okay. And so we may want to actually increase our audio detect distance at this rate, because things that are that far away, he won't be able to hear anything. But anyways, okay, so now we're going to do this. And let's go ahead and I'm going to just move this print to the bottom and just kind of keep printing more values here. What am I doing? Do I just do not know how to type? That's a comma. Okay. Save that. Okay, so our perceived volume is really low on that. You see that? 0.03. This is a 0.2, 0.3. Okay. So given that our slime, the minimum audio sense, that's pretty. I'm going to actually change this to 2.5. I'm also going to change this number to, I think it needs to be bigger. I think it needs to be like 512 by default. So it's actually quite far away. Let's go ahead and run this again, because changing those defaults is going to mess it up, I think. Okay, so these sounds are registering at, that was 0.1 and 0.3. Okay, so like the slime might be able to hear that. This is getting within the realistic range, I think. And so I think the thing I want to tweak most in the future probably is the minimum audio sense. So I would say that this slime is kind of dumb, and so I might increase this actually to 0.5 for him. But I think a default of 0.25 is good. That means that about this distance, see this 0.27, that would have registered to an enemy with 0.25. But with the slime having a 0.5 audio sense, he's not going to hear that sound. I think that's working pretty good, don't you think? Now, I think the only thing that's left to do, now that we've done that, is we need to just do a comparison. So we just need to say, if perceived volume is greater than or equal to the minimum audio sense, then we know that we heard the player. I hear you. Okay. Okay, so we've got this. Am I doing anything in here that I don't need to do? Calculating a sound distance, and then we're getting a. I'm gonna rename these so they make a little bit more sense. Sound ratio. I don't know. I don't know if that makes sense, but it makes sound. Okay, just clean up some of this code a little bit. What's my? Oh yeah, I don't need to print that anymore, and I don't need to print this either. Those things might be helpful. I don't know. And I'm gonna run it, and let's go ahead and just see. He might have heard that. Oh no, he didn't. He don't hear nothing. I need to go back. Let's add this sound ratio here. Save that. Oh, yeah, no, I'm barely at 0.4 even right here. Okay, interesting. I need a way to make this make more sense, don't I? Did I just totally like screw up this slime by making him super 0.5 is kind of high, huh? Yeah, maybe I just need to adjust my expectations on this. I think actually what it is I mean, we could get more complicated with the math, but as I'm thinking about this, even a quiet sound, like let's say the enemy can only detect a point 0.2 sound, a point 0.3, and the jump is a point 0.25. But if you're really close, you probably want that enemy to hear that 0.25 sound, right? So maybe what we need is we need our number range to be different so that the like once you're closer than a certain distance, like halfway, then the perceived volume gets greater than it was before. How about that, right? Because right now we're only decreasing the perceived volume, right? Based off of this sound ratio. But yeah, I think we need to do something like that. So what I've got is I think we keep this as is, and then we can maybe multiply it by 2. I don't know. Does that make sense? I think it does. If it doesn't, comment below, and future me will look at it and go, dang it, you're right. So the slime still can't quite hear that jump, but he can definitely hear some other things. Okay? 0.5 is seeming like a pretty crappy limit to put on these. But is this math working? Is this mathing out how I expected it to? I'm not sure it is. Yeah, I guess so. I hear you. He heard the land. Okay, let me just look at this for a second. I think a way to change this might be to have some sort of a curve to it by using some kind of different math. You know what I mean? But I'm not going to figure that out right now. I'm going to be okay with this just as a general basic system, and just knowing that maybe I need to adjust my values a little bit. And I do think I'd like to adjust this so that that slime works a little bit better. Yeah, like maybe this is multiplied by 2.5. I don't know. Let's just try that for fun. And then I just want to see my values I'm debugging here. Okay, yeah, he heard that. He heard that jump, right? Ooh, he almost can hear that sword swing. What does it seem like from a distance? Yeah, it's almost a little bit too forgiving at a longer distance is what I'm not loving about this. But multiply it by 2. And then I think what I'm going to do is just adjust my expectations on this minimum audio, 0.4. And call it good. In fact, what's the default? 0.25. Let's make it 0.2. We could maybe decrease that a little bit, but that might help a tiny bit as well. Okay, I'm just noodling values at this point. Yeah, he's hearing me land over here. He just barely can't hear that sword swoosh. I don't know if you see that number, 0.38. 0.4 is my threshold. He hears it up here. Okay. But, hey, slimes are dumb. So if I were to reset this to 0.2, assuming he's a smarter enemy, then, yeah, he's hearing the sword swoosh. Right? Definitely hearing that. Okay. So the last step then is just to take this and we go, aha, we've detected the player. So what do I need to do? I need to do the same thing we do up here. On body entered, set the target in the blackboard. Okay. So I'm going to come in here and just say, wait, how do I have it? Do I have a reference to the blackboard? No. I was going to type player, but it's enemy. Enemy.blackboard.target equals, and then I just need to get a reference to the player. We know there is a player, so we'll just say get tree, get first node and group, player. Okay. So if this all worked, I'm going to go ahead and delete my debug code now. Save this. And I just don't have like a chase state. But if I go back, well, I guess if we run it, we've got the label displaying that stuff, right? So this will come full circle. Okay, so we see that he has a player. And let's go ahead and let him... he's not seeing me right now. Okay, you know what we need to do? If we have to assume he doesn't see us. So I think we need to set our search timer. Timer. And actually, we have to set our search timer, but only if we don't already see it. This is getting stupid. Okay, here we go. Variable can see player. Bool equals false. Okay, so anytime we do this stuff, we got to update this. Okay, so on body entered, can see player will be set to true. On body exited, can see player is set to false. And actually, this can see player could totally help with this stuff. Like if you remember this bug we fixed at the very beginning, we almost don't need that. So what we do is we just say, if the timer is greater than 0 and can see player not, and not can see player. So we only do this if we can't see the player and we're decreasing our timer. Then what we can do down here, now we don't have to worry about it. We can set the target. We can set our timer equals search duration. Okay, so he's going to have a duration that he's looking for the player. So even if he doesn't see him, he's going to like turn towards the player and start walking that way, most likely. And, you know, if he's got a chase state, which he doesn't right now. But we can see that, yeah, I'll make a sound and then it'll clear. Yeah, there we go. Because this slime isn't turning towards me. Now, to better debug this and make sure this is working, let's just come over here to our slime. I'm going to, let's see, our sensor's on. Debug, visible collision shapes. Let's go ahead and run this with collision shapes and see if it still seems to make sense. Crap, I don't know. Yeah, so that's not the best test. There we go. He heard me. He's looking for me. Didn't find me. So then he's going to stop. He's going to stop at that point. You might want to, add in the ability, like if they hear something, then maybe that search timer is longer. I don't know. But if I stay in Let's see what happens. He can see me. Yeah, so it's not clearing the player. Cool. I don't know about you guys, but I think that's a pretty decent system to add if you want some basic stealth in your game. So now this guy can even detect me. And if we had a chase state, he would face me. We'll have to demo that once we build the chase state. We'll test this out a little bit further and see how well it works. But there we go. We built a audio, like listening sensor for our slime here, and we did it using simple code that doesn't actually, it's fake. We can tweak it however we want. If you really wanted to get in there with those values and change the math to be more accurate to the real world, maybe figure out how real audio attenuation works over distance and build that kind of stuff in, you could totally do that. But for the most part, that's probably over engineering the game, unless you're trying to go for some ultra lifelike simulation or something like that, right? So thank you for watching and sticking around. We worked on some things. You got to see a little bit of how I work. I would have built something like this and then turned around and just recorded myself doing it in this project so that I could demonstrate it for you guys. And then of course there would have been a lot of questions that I wouldn't have even answered or asked. So like I wouldn't have made that audio sensor to begin with, because we decided, or at least I did, decided that I just wanted to make it part of the player sensor. So there we go. I hope you guys are having fun following along. I've got a few more videos coming, and then we're going to be building enemies using all of these tools that we've got here, and that's going to be pretty fun. And part of the homework for you guys at this point, I think there's two things. One might be to just try and build a certain kind of enemy using the decision engine. But if you want to wait until I demonstrate how to build an alternate decision engine, you can do that. But I think what will be really good is start populating your levels with these enemies. This is a hard one. You can't show it to me very easily, but if you're in the Discord server, then go ahead and send me an example of some levels that you've got that have enemies populated in them. And yeah, just let me know how it's working for you. And maybe if you run into any issues or you have questions, drop them in the comments or join that Discord again and go ahead and drop them in there. And of course, subscribe if you're new. And as always, we'll see you next time.